Hello everybody, I'm Nikos. Got some shameless advertising here. I need not digress. Thanks very much for TRG Recruitment, who I'm not affiliated with, but thanks for the pizzas. I'm doing a video for my YouTube channel called the JavaScript Recruiter Roundtable, which if you're interested, you're welcome to join me. And I'm also planning an event called JavaScript for Recruiters. So when they phone me, I won't get questions like, do you know Java or JavaScript or something? So, now I realize it's quite a long day today and you're probably really knackered and you probably don't want to listen to me. But the good news is in this talk, I have 3 jokes. But the bad news was that was the first one. And that's the second one. Right, and I'll leave the other one optional. I have a YouTube channel. To do with programming, at the start I was kind of really serious about it and I had thumbnails. Then I got a bit lazy and just let YouTube pick the thumbnails for me. Alright, so I'm going to talk about TypeScript first, then I'm going to talk about AWS Lambda. Got any battery in here? Has anybody here used TypeScript before? About 30%. Okay, I'm just going to run through the basics of TypeScript in 10 minutes. Normally I have to take a course to do this, but we'll see how far we can get. Okay. TypeScript was invented by Microsoft, and I started using it in 2012. So I'm a 5-year-old TypeScript developer. So any recruiters that say 5 years experience with TypeScript, I'm your guy. This is a chart, and I'm going to do some technical analysis on this. So this is the blue line is TypeScript. Sorry, it's a bit small, that picture, but and the red line is Angular 2. And so here we have TypeScript going along, big spike at the start, and then I put this dip here to Brexit, and then we have this Angular 2 curve, which really starts to bring up TypeScript quite well. And the great thing is now with Angular 2 sort of dipping down a little bit, and TypeScript still growing. So we're now independent of Angular as a dependency of our growth. So it's a superset of JavaScript. It means that it can do everything that JavaScript can do. So if I do var I equals 1, was there a laser on this thing? I don't know. So this is TypeScript, and this is JavaScript. Anything you take from here, if it's valid JavaScript, and paste into here, in theory you shouldn't get any errors. It keeps the JavaScript syntax, blah blah. Optional types, so you can have an application where you just want to do some typing, and if you don't want to have typing, then you don't need to have types. For example, a type would be number 1, like this. The compiled output doesn't include the typing information, but it's a compile time check. So if I do something like 1 like this, it's going to give me a compile time error, which saves you a whole raft of bugs that you normally discover in the browser. It's compatible with ECMAScript. Okay. Yes. There is so much stuff that TypeScript does. It would take about 2 weeks for me to explain, but I can't because I don't know it all. But it basically, they have who's heard of tuple types, type guards, unum types? Maybe some of us have heard of generics. We're on TypeScript version 2.3 now. Copying ES6 stuff, ES6 modules, destructuring, decorators, JSX support 1.6. That was a bit controversial, by the way. People didn't like React. Yeah. Control flow analysis, augmenting module scope. I don't know what they are. So anyway, so here's I have a Space Invaders game, and I use TypeScript for it. It's all vanilla JavaScript. So I have things called interfaces. So if we say interface foo, and we have type 1, we can actually assign that to var thing and make it a type of foo. Right? Now it's going to complain here that this does not have a type property. So we do that. Then it's going to... Sorry, one is not a type. That's the trouble with live coding. Type equals 2. Okay, cannot find type.
You need an assignment after 2.
Come and help. What's that?
You need an assignment after 2 for the curly.
What?
You're missing the equals character. After 2.
Ah, right, sorry. I'm a bit nervous, aren't I? So, okay. Sorry, that's it. All right, I've got a backup here. I knew this would happen. Cut the last 4 minutes. So, this is an example of like, let's see the interface. So, you have things called abstract classes, which, who's done Java here? Java. So abstract class is something you never instantiate, but you can basically extend it, but not actually instantiate it. So you have the support in TypeScript. You can also have, you can actually implement, actually that's what it implements. So here's an interface called boom shake the room, boom, and it's got a property called boom, and it's got a type of number. And then, so if we say, if you remove this boom property, it's going to complain that this class does not correctly implement the interface. Put it back in, it's happy. You can also do it with objects, which I had a nervous moment there where I forgot the word interface, implements. You can have something called generics. So this is a generic function. Anyone heard of generics? It's a way to make reusable functions. But once you use them and declare them, you keep the type information. So for example, what this is saying is, I have a function here called generic, and it has one generic type, and we pass in type and return the same type. And the function here must return that type. And if you want to use this function later on, like, if I can do it. Basically, if you say var item equals generic and then pass it into string, that item will be typed to a string when you later on use it in the code. Same with the number, it sort of remembers itself. Quite useful. Okay, back to the presentation. So here's an example of a game object in my game, and so this is a method, an interface called iGameObject, in which I draw update methods on the object and position properties. And so this, you can also use it with React. TypeScript have this, there's a repository called definitely typed, and you can download typing information for various libraries, React, Angular, Moment, and then you can have code completion, compile checks at the development time. So for React, you just install Webpack, you install types React and types React DOM. Okay, let's go on to. So yeah, there's TypeScript used by React here. So you can use the framework and its typings, and you can use your own TypeScript libraries as you develop. Okay. Angular 2, let's skip all this. Okay. So let's go on to serverless. It's trouble when you rush, sometimes you get. So who's had a serverless framework here? So what serverless does is allows you to sort of use one common configuration to deploy to various platforms like Azure, Google Cloud, and AWS. What it does with AWS is, well, actually that's the one that I've used. You have this YAML file, and it generates this template that gets uploaded to Amazon, which Amazon understands, and then that then creates a whole bunch of resources for you. So, I mean, if you go on here and watch the video, it explains the process for that. What I just want to show you guys is how you can use TypeScript to strongly type your functions that you then deploy onto the cloud. So last night, 1 o'clock, I was preparing preparing this stuff, but I think one of the guys over in the serverless framework was quite helpful to get this to work. So here is, I've created this example here for how to use this serverless in TypeScript. Now, a Lambda function is a function that you can, it's a node, basically a node file, and it runs as a function as a service, which means that you don't have servers running all the time. They boot up when you have an event for that function, which is a node function, node 6.10. And so what you do is, let me just see. So here's an example of a function node that you would use with. So this is just JavaScript, and it runs on AWS Lambda, and it has, this is how, you have an event thing, which is the event that called the function. So in our case, it'll be an HTTP event, so you get access to HTTP event stuff. It could similarly be a Lambda function that's executed on an Institute of Things device, or an S3 event, like an image upload to an S3 directory. Is all different events that can happen on the AWS platform. So what we're doing here is we're importing the AWS SDK, and then we can use this in the later on in the code to do things with the SDK. So we're just basically sticking something in a database. Now, there's no typing information here. So what I've done is I've created another project, and I've created it in TypeScript. Now, we can't upload TypeScript to AWS because TypeScript is not supported in AWS node. In fact, TypeScript doesn't run on its own runtime. It has to be transpiled or compiled to JavaScript. So what we need to do is we need to take this TypeScript file here and turn it into JavaScript. Now, I'll just compare both of these files. Okay, so this is TypeScript 1 here, and this is the JavaScript here. As you can see, there's not really much difference at all, really, isn't there? There's very little. But when you're using this, you will get feedback from the TypeScript if you're doing something dodgy. Like so, for example, if I start deleting stuff on this item here, which is just an object, eventually something will complain. It does. I tested this last night. So, okay, so basically, it's complaining on this method here, dynamodb.put, right? So if you say it's red under here, see there's that red line? Then I change the font colors. It's kind of hard to read, isn't it? So WebStorm is sometimes not the fastest IDE out there. Close your eyes, everybody. Okay, is that better or worse? Right, so params here is moaning. Now this is just a plain old Pojo, right? But I mean, can you imagine like a normal JavaScript IDE would be able to tell what's going on here? So I'm actually going at an object, deleting an item, and TypeScript knows that it's not of a specific type. So that there just saves you having to bother even learning the AWS SDK. You can just start using stuff within reason, right? And you can use whatever TypeScript library you want, other code that you have. You can use interfaces. You can do anything in here with the TypeScript benefit. So I'll just delete this here. So now, if I actually click on this method here, because I've got the my package JSON here, I have types AWS SDK. Then we have access to all the typing information for the DynamoDB, which is Amazon's JSON storage database. So click on the put here, then that parameter, that object that wasn't actually being allowed to pass in, all the typing information is in this what's called definitely typed TypeScript. And actually you can click on this put parameter, which extends this thing here. And then there's some typing information that's causing it to fail. So it saves us a lot of effort. Now, what I'm going to do now is I'm going to turn this into a JavaScript file. And I use a configuration from a tsvig. My output is ES6. If you output ES5, I don't actually know if that will run on AWS, but probably will. But anyway, I like to read ES6 because it's a lot easier to understand. I mean, if I go in here, here we go again, like class foo. Okay, let's do that, right? And then, I mean, you can just see what it's being output here is like. Now, in ES6, you just give a class, right? So what I'm doing, I've got you have to install TypeScript globally, and you just run tsc, and it's going to look at this TypeScript file and output a JavaScript file for me. This one. So if we actually just compare this to the original one that I copied, pretty much very similar. There's a little bit of, well, that's really similar, isn't it? So this is the JavaScript. So what it's basically doing is removing some spaces. So you could almost write your work for a client and they don't use TypeScript, and you just use TypeScript in the background, and then you send this JavaScript code to the client. They wouldn't kind of know the difference because, I mean, it's quite similar. And so what you do then is we have this function here, and the serverless framework, all the configuration for this CloudFormation template is sort of condensed into the serverless YAML file. And when it deploys onto Amazon, it creates the official CloudFormation template that nobody would write by hand nowadays when you've got things like serverless. So this is really goes on and on and on, but the actual serverless file contains a lot of information in it. So let me just take you through what's going on here. So provider, this is like Azure or X provider for cloud functions. You have a region, which is London, what node environment, and then you have some environment variables like the name of my table here. There's some authentication permission stuff going on. This is my function. So I'm saying I want my Lambda function to basically point to this output JavaScript file here, and it's going to respond to HTTP events. So there's something called API gateway on the AWS Lambda. So when I run serverless deploy, it creates all these things, including this DynamoDB table here. And so let's just see. Let's go to, this is London I'm in. Let's go to Lambda. So this is my function here that's put up there for me. And it's also wired up to API gateway. So it has our to-dos, and when a post is executed, it then executes our Lambda function. So instead of faffing around with the console, connecting all these things together, serverless does a lot of stuff for you. And when you want to deploy this project, you just go on to the place that has a serverless file and run serverless deploy. And what it does is it packages everything, including all the node modules, into one big massive zip file. Azure doesn't do that. They actually download the dependencies on their side. But anyway, this is how it does it here. Package it into a zip file with the CloudFormation template, and then gives us our endpoints. And then you can actually just go in here and execute it. So I'll just click. I'm going to post with curl. Some more text, some len serverless. Okay. And then if we go into our DynamoDB table, we should have one in there. Oh, what's the last one? What's the last one? Do you know? The biggest number, I guess, right? Right, this one probably, right?
No, it's the third one.
The third one? Really? All right, so that worked. Good that you're good at counting 10-digit numbers. That's it. That's my presentation. 90% of it went smoothly, so.